Okay, this video is going to restate rules 1, 2, and 3, and I hope that you find it helpful because I'll also cover the more complicated graphs that are shown for monopoly and monopolistic competition. It's the same analysis that is done for perfect competition, but again, the graph is more complicated. So to begin with, Rule 1, remember Rule 1 tells you in order to get the highest net profit possible or lose the least, the best quantity to produce is the quantity where marginal revenue equals marginal cost. So Rule 1 only tells you quantity. Rule 2 tells you, well, if you want to know if the firm is making a profit or a loss, then you have to compare price and average total cost. If price equals average total cost, they're earning a normal profit or an economic profit of 0. If price is greater than average total cost, then they're earning an economic profit. And if price is less than average total cost, they're experiencing an economic loss. Well, when a loss is being incurred, then you have to apply Rule 3. Rule 3 just asks you to compare average variable cost to price. If the price is at least equal to or greater than the average variable cost, in the short run, you continue to produce the quantity where marginal revenue equals marginal cost. However, if the price you're getting is less than your average variable cost, then in the short run you shut down and produce 0. If nothing else changes to improve this loss situation, then the firm would exit the industry, but that only occurs in the long run. So that lingo of exit the industry is a long run condition. Okay, I'm going to skip a few pages here and get to the graph of a monopoly. Okay, it looks like I went too far, so let me scroll back here. Okay, let's use this graph as our starting point. This is the graph of a monopoly. Not all monopoly graphs are drawn in the same way. I tend to draw mine in this manner. My marginal cost curve looks like a check mark. Here's my average total cost curve, my average variable cost curve, my demand curve, which is where we measure the price from, and then the marginal revenue curve. Now mathematically, the marginal revenue curve lies about halfway below the demand curve. So it's always separate. And again, you're going to use Rule 1, 2, and 3. In this particular exercise, I asked my students in class to label the profit maximizing quantity as 3,000 units, label the price for each one of the 3,000 units as $20, and then to do all these calculations. So we'll just worry about profit per unit, total cost, total revenue. So again, with this graph, you start with the marginal cost curve. When it hits marginal revenue, you stop and go straight down, and then you're going to draw that obnoxious line up and down through your graph. I'm going to switch now to a PowerPoint slide to do this. Okay, here's my PowerPoint slide. Here's my marginal cost, my marginal revenue. I find where the two intersect, and then I draw a line straight down to my quantity, which I think was going to be 3,000. And then I'm going to draw that obnoxious line up and down through my graph. So here's my 3,000 units, and there's my obnoxious line. Again, don't worry about all these curves out here. Don't worry about the curves here. What you're looking at is for 3,000 units, what is the average variable cost? What is the average total cost? So you're looking at where 3,000 is associated with those two other curves. First of all, I said for my example that I'm doing this in class, the 3,000 units of output, you go straight up to the demand curve, and that's the price that will be charged for each one of those 3,000 units. In this case, I arbitrarily picked $20 is the amount. Okay, so if we know right away at this point on the graph that we've got 3,000 units of output, we know that $20 is the price. I hope you look at that graph and you can also tell that something else is $20. What would that be? Well, in this case, the average total cost curve also happens to intersect for 3,000 units at $20. So this axis, which measures both cost and price, well, in this case, $20 happens to be ATC, so you could write ATC equals 20 equals price equals 20, and those would be true statements. So in this case, the total revenue would be 3,000 times $20, so that would be 60,000. The total cost, well, that would be 3,000 times $20. Again, that would be 60,000. And then you could determine that their profit would be 0, or it would be an economic profit of 0 or a normal profit. Remember, a normal profit would be a profit that would allow them to pay all their explicit and all their implicit or opportunity costs. So don't forget that we make that distinction in economics about how we view costs. Okay, let me go to this next slide. Okay, then I went on and in class I calculate the total variable cost, and let me just step through that for a moment. For 3,000 units are associated with this point on the average variable cost curve, which I'll call $14. So 14 times 3 is their total variable cost. And okay. Oh, let me go back to another back to the word form of this particular document so that we can look at the graph with all these notations on it already. I know that the graphs for Monopoly can be pretty intimidating. Oops, went a little too far there. As I say, I know that graphs for monopolies can be pretty intimidating looking, but if you remember that you're doing exactly the same approach as what you did with perfect competition, and try not to get like freaked out that this is so much more complicated looking. I know it is, and it definitely is. But again, the steps and the approach you're going to use is exactly the same. You're going to start with the marginal cost curve. You're going to follow it till it hits marginal revenue, and here's that marginal revenue curve. From there, you're going to go straight down, and then you're going to draw an obnoxious line up and down through your graph so that you're able to do all the necessary calculations. In this case, I said label the profit maximizing quantity as 2,000, label the price for each of these 2,000 as $40. The main thing you have to keep in mind is the price for monopolies and monopolistic competitions always going to be greater than the marginal cost. So the price is always measured from the demand curve. So okay, let me just kind of walk through this for a moment. Here's MC equals MR. You're going to go straight down. You're going to label that 2,000 units. You're going to draw an obnoxious line up and down through this graph. In this problem, I said, okay, let's call the price for each one of these 2,000 units $40. So straight up from 2,000 till you hit the demand curve, go over to the price and cost axis. You label that $40. And then, well, I've asked my students to do some calculations of total cost, fixed cost, variable cost, profit. And so if you look at this curve ahead of time, before we actually go to the slide that shows it done, MC equals MR, go straight down, that's 2,000. Here's the point at which average variable costs are associated with 2,000 units. So average variable cost is right here. Keep going straight up. Here's the average total cost for each one of those 2,000. And then straight up to the price, again, which is $40. So let me switch back to the PowerPoints. Okay, so marginal cost equals marginal revenue. There's my 2,000 units. Here's my obnoxious line up and down through my graph. For 2,000 units, here's where 2,000 is associated with average variable cost. I'm going to call that $20. Then I'm going to go straight up and, well, this line is average total cost, and it's the average total cost for each one of the 2,000 units. And I'm going to call that $32. And then this would be the price, which again was given by the problem. You were asked to use a price of $40. So from there you can calculate total revenue. Well, total revenue again is always price times quantity. In this case, the price is $40. The total and the quantity is 2,000. So 40 times 2,000 is 80,000. And then you've got total cost. Well, total cost would be $32 times 2,000, and that would be 64,000. If you wanted to calculate average variable cost, well, average variable cost would be $20, or sorry, total variable cost. Total variable cost would be average variable cost of $20 times 2,000, which would be 40,000. But we're mainly interested here in figuring out quantity, which in this case is 2,000, price, which is 40, and profit. And if the total revenue is 40,000, if the total costs are 64,000, then the profit is the difference, which is 16,000. And the profit per unit, well, profit per unit is price, 40, minus ATC, which is 32. So the profit per unit is $8, and then you can multiply that by 2,000 to get the $16,000 profit. Okay, let's see. Let me go back again to another graph. Looks like I've already got this one done as well. So, okay, let me return to my PowerPoints. Okay. Or my Word document, sorry. Okay. Here's a graph of a, whoops, I went a little too far there. Here's a graph of a monopoly. I'd like you to take a moment to look at this and see if you can figure out the answer to the question, are they winning or losing the battle? So what'd you decide? Are they winning or are they losing? If you want to know if they're winning or losing, I'm talking about are they making a profit or are they making a loss? In this case, you can see that the demand curve or the price line is this line. And up here above the price is the average total cost. So obviously in this case they must be losing the battle. So what I've asked my students to do is, and let me get this a little bit lower. Again, label the best quantity to produce is 1,500 units. So you start with the marginal cost curve. You follow it till it hits marginal revenue. You go straight down and you label that 1,500 units. Then you make this obnoxious line up and down through your graph from 1,500 units. And all you're going to worry about and all you're going to look at is that obnoxious line to determine price, AVC, ATC. So straight up from 1,500 units till you hit the demand curve and go over to the price axis, we're going to call that $40. So if this $40 is what each one of these 1,500 units are selling for, then obviously average total cost is higher than that, and average variable is lower. Let me return to the PowerPoints and go through the values that I used for that one. Okay, so marginal cost equals marginal revenue. Go straight down, 1,500. Go straight up. Here's the average variable cost per unit, 32. Here's where 1,500 is associated with the demand curve, which is the price that we're willing to pay for those 1,500 units. In this case, let's call it $40. And then if you keep going up, this is the average total cost for each one of those 1,500 units, which we'll call $52. Now, again, because they're losing money, Oh, by the way, and how much are they losing? Well, I'm going to do this in a little backwards way. You can say total revenue, which is price times quantity. In this case, it's 40 times 1,500. Then you can take total cost. Well, total cost is $52 times 1,500. You can take total revenue minus total cost, and that will tell you the amount of the loss. And I'm just going to kind of, since I don't have a calculator here, I'm just going to back into that total loss. I can tell you that they're losing per unit $12. So 40, the price, minus the average total cost of 52 is $12. So $12 times 1,500 units is their total loss. Okay, now let's see what the next graph might show. Okay, in this case, oh, wait a minute, let me go back. I forgot something. We've done Rule 1, we've done Rule 2. We've compared price and ATC. We've compared marginal cost and marginal revenue to determine what a level of output they should produce. But you know what? This monopoly is losing money. Can a monopoly lose money? Of course. Let's say that I had a monopoly on the infamous widgets. I have a monopoly and I'm going to charge $40 for every widget. Is there any way I can lose money? I mean, I'm the only one that sells them. Well, yeah, of course I could lose money. What if nobody wants them? Maybe the demand is just too weak for these items. So, in this case, this monopoly is losing money. The demand is not strong enough to cover their total cost. The question here becomes, since they're losing money, you have to apply Rule 3. And remember, Rule 3 says compare average variable cost and price. Well, in this case, the price is $40 and the average variable cost is $32. So that means the price is greater than the average variable cost. So I suppose if you want to really analyze this, you could say, well, the average variable cost per unit, the direct costs that go into producing every unit of output, is $32. Of course, in addition, they have their fixed costs, but they have to pay those anyway, whether they're producing anything or they're producing 1,500. But since the price is $40, then what that suggests is that the $8 difference, $40 minus the 32 average variable cost, means that $8 are going towards their fixed cost. $8 is going towards their fixed cost. Remember, the difference between average total cost and average variable cost is the average fixed cost. So for every one of these units that they sell at $40, they're paying all their variable costs, $32 to produce each unit. They're paying $8 towards their fixed cost, which are $20. If average total cost is 52 and average variable cost are 32, the difference between them, which is 20, represents the fixed cost. So they're absolutely better off. They're better off by producing 1,500 units than producing 0. So, because price is greater than AVC, in this case, they would continue to produce in the short run, and they would produce 1,500 units of output. Okay, here's another graph, and I won't switch back to show it without this analysis. I want you to remember also that the graph for monopoly looks very, very similar to the graph for monopolistic competition. And the reason that's important is because if you know how to analyze one market model, this one we call monopoly, then you also really know how to measure the graph for monopolistic competition. So in this case, well, let's see. Here's my demand curve, which demonstrates the willingness to purchase the product at every given price. Here's the marginal cost curve. I find where it intersects marginal revenue. I go straight down, and we will call this 1,200 units. Then I draw my obnoxious line up and down through my graph. And here's where 1,200 units is associated with price, the demand curve, which we'll call $40 again. And then if you keep going up, here's where 1,200 units are associated with the average total cost curve. We'll call that $55. And this would allow you to do all the calculations necessary. If you want to calculate total revenue, it's $40, the price, times 1,200 units. Total cost, well, it's $55 a unit times 1,200 units. And the difference between total revenue minus total cost, in this case, is a negative number, meaning that they've experienced an economic loss. And then if you take the price, $40, minus the $55, 40 minus 55 tells you the loss per unit. And in this case, it would be $15 a unit. So in this example, I'd like you to look at the graph and tell me, what does that $15 per unit loss represent? If you're kind of getting a feeling for these graphs and getting to feel more comfortable with them, you should know that this vertical distance between the ATC and the AVC represents the average fixed cost. So in this case, the average fixed cost for each one of these 1,200 units is $15. And that's what is not being covered by the price. The price is paying for all the variable cost. It's not paying the fixed cost. So again, in this example, they're losing money. So you need to apply Rule 3. And what Rule 3 says is to compare price and average variable cost. Rule 3 goes on to say that if price is equal to or greater than average variable cost, you continue to produce at a loss in the short run. And in this case, the price is exactly equal to the average variable cost. So by producing 1,200 of units, you are losing money, but all of that money that you're losing is the fixed cost, which you have to pay anyway. If you produced 0, you would lose exactly the same amount of money. But the difference is, by producing some amount of output, hopefully this monopoly can refine its production techniques to become more efficient. Okay, I wanted to find this one. Actually, there's two examples I want to finish this video off with. This first one, again, this is things that I do in my classroom on campus. And this first one shows 3 curves, and it tells you in the example that it's for a perfectly competitive firm or competitive firm. And it asks you, first of all, to label the curves. Well, this is the one that looks like a check mark, so we all know that's the marginal cost curve. This one is the average total cost curve, and then the average variable cost curve, which always has to lie below the average total cost. Then it asks you to draw the demand curve. We're going to call it D1 at $8 and assume that this firm earns only a normal profit. Now, you know, I don't have a graph to show you that is completed, but I'd like to at least walk you through the motions of how this question would be answered. Okay, if I'm working with a perfectly competitive graph, then my demand curve is horizontal. And in part B, it asks you to label that demand curve D1 and call it $8. So let's say that I would just draw a horizontal line going straight through this point. This is the important point because the question says, well, they have to earn only a normal profit. So that means that ATC has to equal price. So that horizontal demand curve would go right through that point. We'd call it $8, and then it asks you to label the profit maximizing quantity as 800 units. Well, again, you have to imagine that there's this horizontal demand curve going through this point. And remember that this horizontal demand curve for perfect competition also represents marginal revenue. So price and marginal revenue and demand and marginal cost have to meet. Marginal cost and marginal revenue have to equal, and that determines the equilibrium or the the quantity, the best quantity to produce at 800 units. So right here at this point where MC equals the demand curve, which is also marginal revenue, you go straight down and label that quantity 800 units. The next question I asked on this example is, what is the break-even price for this firm? Well, you know what break-even, that particular expression means? That really means, is a very business type expression. What it really means is that a firm is earning a normal profit or an economic profit of 0. Well, the break-even price then would be $8, because at $8, the average total cost equals the price. Then it asks you, well, what is the lowest price this firm would be willing to accept for its output in the short run? Well, remember, the lowest price that a firm will be willing to accept for its output in the short run means, okay, if they're losing money, what's the very least they'd be willing to lose? And that would be the amount when price is equal to average variable cost. So going back up to this graph, and again I'm asking you to imagine that I've drawn this horizontal demand curve at $8, and at $8 here's where the average variable cost curve lies. And again, the price, the lowest price they would be willing to accept, it would be this price. Whenever price equals AVC, that's the lowest price they'd be willing to accept. So if I was looking on this graph, I would say, okay, if this is $8, then down here must be about, I don't know, $5, $6. So again, the lowest price is when the price equals the average variable cost. Okay, label the firm shutdown point, longest run shutdown point. Okay, I'm going to skip F and G, and then the last question here is, draw a demand curve, we'll call it D2, that will cause this firm to produce 0 in the short run and exit in the long run. Ooh, that's a pretty tough one. Draw a demand curve that will cause this firm to produce 0 in the short run and exit in the long run. So you're being asked to add a horizontal demand curve, another one, to this graph. And this one would cause the firm to produce 0 in the short run and exit in the long run. Where would you be willing to draw that graph, or where should you be placing that demand curve? Hopefully you realize that the demand, which is the price line, would have to be below the average variable cost. So again, here's my average variable cost curve. If the price was anything lower than whatever this average variable cost is, then they would produce 0 in the short run and exit in the long run. So again, you should be drawing the other demand curve right below, at least below the average variable cost. Okay, I'm going to pause and I'm going to switch to one more slide. Okay. This is another graph, and in this, if you notice, in every graph that we've done on these videos, I've determined or picked arbitrarily a quantity that I'm asking you to label and a price that I'm asking you to label, as well as picking a value for AVC and ATC. So I'm going to ask you to look at this particular graph, and this graph allows you to determine those values yourself. Here's the marginal cost curve. Here's the marginal revenue curve, our average variable cost, our average total cost. Here's our demand curve, which of course is where we measure price. So if you take a moment to look at this graph, I'm going to ask you, first of all, what is the best quantity for this firm to produce? Meaning, apply Rule 1. Now, I can tell by looking at this graph that this line's a little tiny bit off. I don't mean it to be off, so think of it as intersecting exactly at the square. So, what did you come up with? Did you determine that the best quantity to produce to maximize profit or minimize losses, in this case, would be 400 units of output? If 500 is 5 squares, then these 4, each square must be representing 400. So if MC equals MR at this point, then the quantity, the best quantity to produce would be 400. You're going to do the same thing as before. You're going to go right through this point. You're going to draw an obnoxious line up and down through your graph. It should be exactly on that dashed line behind my cursor. And okay, the first question is, what's the best quantity? Well, in this case, the quantity is 400. You go up to the demand curve, over to the price axis, and now you get to determine what the price is. So what would be the price for each one of those 400 units? Hopefully you came up with $27, because if this is 15 and then you got 5 squares and that's another 15, then each one of these squares must represent $3. So that means this would have to be a price of $27. Okay, so you know the price is 27, the quantity is 400. You can calculate total revenue by taking 400 times $27. In this case, look at your graph. Do you think they're winning or losing the battle? Hopefully, you're more comfortable with the graphs. You can see, hey, the ATC, their average total cost lies up here, but their price is down here. So obviously, they got to be losing money because their costs are higher than the price. So again, you're going to have this obnoxious line drawn right through your graph. And here is where the average total cost is associated with the 400 units of output. So what would the ATC be for each one of these units? The average total cost for each one of the 400 units would be $36. Okay, so now you can calculate total costs, and total cost would be $36 times 500, or sorry, excuse me, $36 times 400 units. The net profit or loss is just total revenue minus total cost, and since we have a negative value, that means they would be losing money. I asked my students in class to determine for this firm what would be the break-even price. And when I ask that question, break-even price, I'm asking them, hey, what would the price have to be for this firm to earn a normal profit? Well, here's where their average total cost is. So the price would have to be $36 because then price equals average total cost. And that means they earn a normal profit. Now, let's go back to this example for a moment. Here's my 400 units. Going all the way up to my average total cost curve. What is the profit or loss per unit? The profit or loss per unit. Well, remember, you can take, if you've calculated total revenue and you subtract a total cost, you have the total loss, or the economic loss, and you can take that total loss and divide it by 400 units, and that would tell you the loss per unit. Or you can take price, in this case, which is $27, minus average total cost, which is $36, and that would tell you the loss per unit is $9. Then you're asked this last question, and it says, well, what would the short run net profit or loss be if they produced 0 units of output? It's a good question. I'm not sure if I asked you this on the test. Probably not, but I still think it's a good question to touch on. And that is, first of all, here's the average total cost per unit. It's $36. Here's the average variable cost per unit. Well, that happens to be $18. So 36 minus 18 is $18. And that tells you that their average fixed cost per unit is $18 when they produce 400 units. So if they were to produce 0, they would still have to pay their fixed cost. And their fixed cost would be 400 units times $18. So you'll find that if they did produce nothing in the short run, they'd lose more than if they produced the 400 units. And another way you can see that is graphically, here's their quantity, 400 units. Here's the average variable cost, which is 18. The price, well, the price is 27. So 27 minus 18 means that there's $9 going toward the fixed cost for every one of the 400 units sold. Okay, so hopefully these two videos will help you feel more comfortable with the graphical analysis that you have with the 4 market models: perfect competition, monopoly, monopolistic competition, and oligopoly.